Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This episode will be about finishing up the Retro Challenge, finding a new scripting language, finding a new home computer, and 555 music. Hello and welcome back. As usual, it's possible to send feedback to the podcast. You can use the email address on the podcast.cba.si page for that. A friend of mine suggested that it would be maybe a nice idea to make this a video podcast on YouTube or something like that. And yes, maybe that is nice, but I think it would take much too much time for editing and so on. And also recording with just a microphone is very easy. You can set wherever you want and it's pretty fast. And it needs to be fast, else I wouldn't do anything. I think last time I talked a little bit about the EMF camp in England in September, I think. And there was a sale, the last ticket sale, and it went remarkably fast. And in fact, it went too fast for me because by the time I wanted to order a ticket, they were gone already. Now, with the help of a friend, I was able to get a ticket, so that's very nice. And that means I'll be going there in September. It's not going to be a very long episode because I didn't do a lot of different things. Mainly, my time went into finishing up my Retro Challenge 2018 April competition project, which was a Commodore 64 cartridge adapter, allowing you to have an intro screen before your cartridge code starts. So you can have an intro screen in hardware, something like that. Between the last podcast and this podcast, the effort went into fixing some timing issues, making the PC software to communicate with microcontroller using USB link or serial link, making a serial command monitor so you can debug it and manually operate the cartridge adapter, finishing up some cartridge code which I made before. It's a small intro. I'll post a link in the show notes for a video of that and also a video of the device completed. So what I need to do was relocate that and add a spacebar routine, and that was basically it. Also add a lot of hack wires and capacitors and resistors to the board. So I'll post a picture of that. It's not very pretty, but it works now. And test the device, and everything seems to work. I have to test it with actual cartridges, but I only have one cartridge to test, and that works fine, I think. So I'll have to test it with a couple of actual cartridges, and then I'll call it done. I made two devices, so one is going to Awesome Space in Utrecht and one other one is going to the Bonami Computer Museum in Zwolle in the Netherlands. And for that I'll still have to make a small intro with our logo and some text and so on. Now, the last time for a different project, namely the cassette tape IFComp entry project, which is basically an interactive cassette tape that will tell you when you play it, when you are in a adventure game and what's going on, and using play and rewind and forward you can make choices and you can basically control your character and move around in the world. So when I talked about that a little bit, there was a decision between using an onboard flash for program and world storage on the PCB or using an SD card which you can remove. Now, and I chose to do I think I would choose a flash in the form of an IC on the PCB instead of an SD card which you can remove, because with an SD card I said there would be you have to implement a file system and read from that, and there's possibility for extra bugs, so I wouldn't do that. However, for this recent project, the cartridge adapter, I also use an onboard flash. Now, in this case I had to use a parallel flash because the home computer expects something parallel to write to and read from basically. But right now communication from the PC to the cartridge adapter used to upload firmware images, to upload cartridge images, is done using a serial link. Now that works fine. However, if you have different operating systems, for example Windows or Mac OS or Linux or whatever, you need to have either a scripting language on either operating system to send to the PCB, to send to the microcontroller, or you would have different programs on each platform. Now, I think a scripting language would probably work, but all those problems are gone if you use a SD card, because you implement file system read code once on a microcontroller, and then simply the problem becomes the user's problem. So he or she should put cartridge images on there using whatever means he or she sees fit, and that's it basically. And then insert the SD card, and that's it. And inserting an SD card or changing cartridge image code is something that you would not do often, so it makes sense to have that on an SD card. It's not easy to do. Uploading using serial link is easier, but the SD card is less work for me, basically, because you only have to do the file system code once. So for an upcoming version of the cartridge adapter, I might do that. Talking of which, during the project there were a lot of flaws, and I'll list these just to let you know that I fail a lot. In random order, I made a diameter of some holes for connector pins too small, so the connector had to be jammed in. That wasn't very pretty. Also, for a lot of pins, a lot of signals, I used the wrong pins on the microcontroller. For example, the transmit and receive coming from the USB bridge IC went to the wrong pins. Address signals were mixed up. Other address signals were mixed up, so that wasn't very nice. I should have used a shift register in combination with a smaller microcontroller instead of a big fat microcontroller and doing everything in parallel, because that's more flexible when you are layouting, I think, because you can move groups of pins to an area where it is easier to lay out those pins. Then I placed the debug and upload connector to the microcontroller very inconveniently on the PCB, so you couldn't upload and debug while the PCB was plugged into the Commodore 64. Next time I probably should use an SD card in addition to a parallel flash to make changing cartridge images much easier. Also should put a big "this side up" text on the PCB to hopefully prevent people from inserting the cartridge adapter the wrong way around, because the cartridge adapter of the Commodore 64 is symmetrical. Now I didn't check if you would actually cause damage if you flipped the cartridge adapter, but it doesn't hurt. I forgot some low pass filters on some pins, and the serial command monitor is not very convenient to program against, so I should change that so uploading becomes faster. So you see, this is a relatively small project and still a lot of stuff apparently goes wrong. Now for the PC software in this project, I used to communicate from the PC to the PCB using a serial link. There was a time when I did a lot of stuff using Perl. And when you use Perl almost every day, you become pretty proficient in it. At least you don't have to look up many commands how to do something. You pretty much know how it is, and it becomes like a Swiss Army knife. You can use it for everything, and most of the stuff, most of the keywords and most of the commands are in your head, and you know how to use it quickly. I don't script nearly as much as I used to now, and to be honest, I don't have a scripting language of choice now. For some things I use Tcl, TCL. That is nice. However, there are hardly any libraries. So if you want to program against something real, like an SQL database or something networked, it's probably possible. I didn't look into it that hard, but it is not as fancy library-wise as modern scripting languages like Python and Perl and Ruby, for example. I looked into Ruby. It seems very nice. I did some programs with it. For example, the conversion of bitmap graphics for the logo I used on the adapter card's Commodore 64 code. That's the logo and some graphic stuff. The conversion of that I did in Ruby, and that goes pretty well, except the same problem occurs there. If you don't use it every day, you forget a lot of stuff. And to be honest, even the syntax I have to look up now. I have to look through my own code. I'll look through a reference manual or read a few manual pages or something like that to get up and running, because I don't use it often enough. So I'm not sure this problem is going to solve itself. We'll see. So that was pretty much all about the Retro Challenge project. Now, this was a project for the Commodore 64 home computer, and when this is done, and I have to test it, but at some point it will be done, and I'm pretty much done with this computer, I think, and I'm going to give it away and get something else or focus on something else. Now, two systems that may be interesting, well, there are obviously more, but two systems that may be interesting are the Atari VCS. That's a very minimalistic and very difficult to program computer. It's a console from 1977. And the Odyssey 2, or in Europe it's called the Philips Videopack G7000, I think, from 1978, if I'm not mistaken. And there was also a console, I think it could do remarkably much for what it is and from its time. So maybe I'll have to look into that. And I know that at a nearby retro computer place they have one of those, and they have a lot of games, and I can use it and I can fix it and I can test stuff on it, so maybe that'll work fine. And to be honest, I like the old home computers, but I think I like consoles more because of the minimalist design. Like you only have basically a cartridge slot and some switches and joystick ports or joysticks, and that's it basically. So I think to make software for that is more like making something do stuff that it wasn't intended to do. So I like that whole idea. It's a home computer was intended to do programs on and to do weird stuff on, but the console is mainly used for games, so I like the idea more of doing non-game stuff on a console. So we'll see how that goes. Now, like I said, the last Retro Challenge project was for the Commodore 64. That was just one type of home computer. But if this is a nice idea and I have to see how it works in practice, then maybe it makes sense to make the same cartridge adapter or the same principle for different home computers, and especially consoles. That would be nice to have an enter screen on a console, for example, telling it what it is, or very quick specs, and then a press space flashing thing, or press joystick button or whatever, and then it would move to the actual game. I think I talked about the Outline demo party in the Netherlands a couple of times already, and I was considering going there and to compete in a 256 byte programming entry, because that seemed like the easiest to do, not the easiest to do, but the easiest to get something to join in a competition. And my idea for that was to use my own homebrew CPU and then a 256 byte program in some way, some form or another. Now it has LEDs on the front panel. Now what you could do is, instead of lighting an LED or parallel to lighting an LED, you could enable a sound. So you can play a sound. Whenever the LED receives power, you can power a sound making circuit. So I tried something like that with a couple of 5x5 timers and I hooked them together so the first in cascade, so the second timer is connected to the first timer's output, and you can make sounds something like this. And if you have, say, 8 or 4 of these circuits hooked to your CPU, you could theoretically make some music and maybe some visual effects in 256 bytes. Now that would be maybe nice, but I'm not doing that because really I don't have time for that. And it's in 2 weeks, I think it's 14 and 15 May if I'm not mistaken, and no way I'm gonna get something done because I have to do actual work instead. So there. I didn't take anything apart this week, or rather I didn't take it apart far enough to say anything useful about it, but still waiting for next time. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye. Fun fact, after only 20 episodes I noticed that this microphone has a front and a back side, and that actually does make a difference.